Okay, so we're going to take a look at our last example, which is not example 3, it's example 5. And we're going to use the sine law in an ambiguous case. Before we look at this example, though, I just want to show you that I found this link here, which will take you to a Java applet that can help you visualize and explore the ambiguous case. It's an excellent applet, and it can also help you with some of your homework. So if you have time, have a look at it. Okay, so when you're working on these questions, the first thing that you really should do is determine whether it really is the ambiguous case or not. So I'm just going to do a little sketch over here of the triangle A, B, and C, where angle A is 30 degrees and B is 25 centimeters and A is 18 centimeters. And remember, we need to know what the height is if we're going to determine whether it will result in 0 solutions, 1 solution, or 2 solutions. So our height is h equals b sine of a. So h equals 25 times the sine of 30 degrees, and we find that it is 12.5. Okay, so that's equal to 12.5. Okay, so we want to make a comparison between h and A and B. Okay, so H is 12.5, B is 25, and A is 18. So you can see from the values that we have here that H is less than A, which is less than B, right? Because 12.5 is less than 18, which is less than 25. And if you go back to your chart on the previous page, you can see that when H is less than A, which is less than B, you will have 2 solutions. Okay, so that means we're going to get 2 different answers for this question. Okay, so we are told A is 30 degrees, side A is 18, side B is 25. We have to determine the measure of the other side and angles, and then round our answers to the nearest units. Okay, so we're going to have to divide our page in 2 because we are going to be working on 2 triangles simultaneously. Okay, so our first triangle is going to look something like this. So here is our side AB and our angle A, which is 30 degrees. Now B is a little bit longer than A, so we're going to draw it like this. So this is C. Okay, so this is 25 centimeters and this is 18 centimeters. And so what we're going to find is angle C and angle B and side C. And our other triangle, and so we'll try to get this 30-degree angle in here, A and B. So side B is 25 centimeters and it's longer than side A, so I think that's about right. This is C, this is 18 centimeters, and here is side C. Okay, so on both triangles we're going to look for angle C, angle B, and side C. So I'm going to start with angle B. Okay, and I'm going to use sine A over A, which is equal to sine B over B. And so sine of 30 degrees over 18 is equal to the sine of B over 25. And so using my little shortcut, sine of B is equal to 25 times the sine of 30 divided by 18. Okay, and so when I work this out, I see that the sine of B is about 0.6 6944. And so when I work out angle B, remember you need to use the inverse of sine. And you get that angle B is approximately 43.98, which rounds off to 44 degrees. Okay, so we're going to find angle B on this triangle too. And if you remember from the previous video, the little discussion that we had on comparing the two triangles that we would get, you know that angle B from your first triangle is supplementary with angle B on your second triangle. And so to get angle B, you can just go 180 degrees minus 44, and you get 136 degrees. Okay? Now, the other way you can work this out is to remember that because your sine ratio is positive, and using cast, you know that sine is positive in the first quadrant as well as the second. So if you have an angle in the first quadrant that has a reference angle of 44 degrees, which is our first angle for angle B, right? And you were to draw that in the second quadrant. Okay. Then your reference angle would still be here at 44 degrees. So if I wanted to work out my second angle, which, why don't I just call it theta, I would go 180 degrees minus 44, which equals 136. And you can see that it matches what we have over on our second triangle. Okay? All right, so angle B on the first triangle is 44 degrees. And angle B on the second triangle is 136 degrees. Okay, so the next thing that I want to find is angle C. All right, it's an easy one to do. And I really can't find side C anyway unless I have angle C. So I'm going to start with that. Okay, so our second step is to find angle C. Now that's an easy one because we already know two angles in our triangle, so we just have to minus those from 180. So 180 minus angle A, which is 30 degrees, minus angle B, which is 44 degrees, gives me 106 degrees for angle C on this triangle. So I will put that on my diagram. So this is 106 degrees. And on our second triangle, we'll use the same method. So we want to find angle C. I already know two angles in this triangle, so I'm going to minus them from 180. And I get 14 degrees. Okay, so this is 14 degrees. Okay, so now on both triangles I'm going to find side C. All right. Now I already have angle A and its opposite side and angle B and its opposite side, so I can use either sine A over A or sine B over B to get side C. So I will use the sine A over A on this triangle, and I'll use sine B over B on this triangle, and just show you that you'll get the same results. Okay. All right, so I'm going to find side C, and I'm going to use sine of A over A equals sine of C over C. And so I'm going to go for sine of 30 degrees over 18 equals sine of 106 degrees over C. So C is equal to 18 times sine of 106 degrees over sine of 30 degrees. And I get that side C is about 34.605, which rounds off to 35. Okay, so I'll put that on my diagram. Okay, and then I will work it out on the next triangle. Okay, and this time I'm going to use sine of b over b is equal to sine of c over c. Okay, so sine of b is sine of 136 degrees over 25, and that's equal to the sine of 14 degrees over c. And I get that c is equal to 25 times sine of 14 degrees over the sine of 136 degrees. And that works out to be about 9 to the nearest whole unit. And so I will put that on my diagram. This is equal to 9. Okay, so we've solved both triangles. And I'll just list the information here. So on our first triangle, we have that angle B is equal to 44 degrees. Angle C is equal to 106 degrees, and side C is equal to 35 centimeters. And on our second triangle, angle B equals 136 degrees, angle C equals 14 degrees, and C is equal to 9 centimeters. And that concludes example 3, and it concludes our lesson on the sine law.